one, start.
Hello everyone, welcome to the fourth HIWeather webinar toward improved hazard forecasting. My name is Jenny Zhang. I'm the lead of the task team to multi-skill hazard forecasting under HIWeather project. Today's program is hosted by Martin Wegman from WMO and will be facilitated by Paul Zhou. Paul is from the Environmental Canada of Climate Change. Although now he's retired, but he is still very active in committees and research. So I'm affiliated currently with the National Center for Atmospheric Research located in Boulder, USA. So without further ado, I'll now turn to Paul.
All right, thank you. We have an exciting 6 presentations here from all over the world. But first, I should say good day, good afternoon, and good evening. The first speaker up is Jenny, and she will provide an overview of the multi-scale hazard forecasting task team. Over to you, Jenny.
Okay, thank you, Paul. So in this first talk, I'll give an overview of the multi-scale hazard forecasting task team research and activities. I'll start with a brief overview of the HIWeather project. The HIWeather project is a 10-year WMO WRP research project established in 2015. The International Coordination Office is in CMA, Beijing, established in November 2018. Brian Golding from United Kingdom and David Johnston from New Zealand are the co-chairs of the project. There are 5 task teams focusing on 5 different themes of research. The overarching goal for the project is promote cooperative international research to achieve a dramatic increase in resilience to high impact weather worldwide through improving forecasts for timescales from minutes to 2 weeks and enhancing their communication and utility in various applications. The scope of this HIWeather project is defined by these 5 hazards: urban flood, disruptive winter weather, wildfire, urban heat waves, and air pollution, and extreme local wind. As the cities are getting larger and larger, the challenge for accurately predicting hazards becomes greater. Partly because the mega cities, they are highly populated, so the hazards can cause tremendous danger and even loss of life to many people. So there are 5 research themes under the HIWeather project. They are organized through task teams. So each task team consists of a number of members. In the multi-scale hazard forecasting, we have currently 9 members from several countries and continents. If you are interested in becoming a member, you can contact me because we still need expertise, especially we need people in the area of coupled hazard modeling. The hazard forecasting involves several key processes, starting from multi-scale observations. These observations can be directly used to produce the hazard forecasting, or they can use the numerical models through data simulation to produce NWP-based forecasting. weather forecasting, or they can be used in nowcasting systems to produce a very short-term forecasting. These weather forecast output have to go through some intermediate processes, including user-oriented post-processing. This has to also provide uncertainty information, of course, and machine learning technology or a coupled modeling. Of course, the coupled modeling is most complex, and it's still mostly in the research stage. A lot of hazards occur in localized regions and in a very short time scales. Even for systems that are large scale in nature, like a hurricane or winter weather. So although we can issue advisories based on current numerical model results, we can tell people the potential areas, large areas, there will be a possibility of a hazard, but we still cannot do specifics of location and timing. So these are really challenging problems. So given the above background, our key research areas focus mostly on the high resolution observation and modeling, or nowcasting technology, including observing kilometer scale weather hazards and impacts, hazard nowcasting methods, coupled kilometer scale data simulation methods, kilometer scale hazard prediction with improved convective initiation, microphysics, land surface interactions, and PDL parameterizations. Coupled kilometer scale ensemble predictions, and advanced user-oriented post-processing products, including uncertainty. These two maps illustrate the current and future global observing systems. On the right, that's the future new observations. These different observations, they really represent different scale of atmospheric motion. So in order to assimilate these different types of observations, there are great challenges for data simulator and modeler. For example, because these observations have different spatial and temporal resolutions representing different scales of atmospheric motions, then the data simulation method has to be able to optimally assimilate different types of observations. But current data simulation system usually either focus on the large scale observations or convective scale observations. So we still have a lot of work to do to be able to assimilate all these multi-scale data observations and to do it optimally for all. Another challenge is with all this big vast amount of data, we need a better understanding and handling this data. And they all have different characteristics. This also poses another challenge. Of course, data pre-processing, quality control, error, quantification, these are all challenges for assimilating all these different types of, especially the new observations. The networks currently quite useful for kilometer scale data simulation include radar, surface station, geostationary satellite, lightning detection, profiler, UAV, smartphone, and etc. Okay, here is an example to illustrate the role of a high-resolution observation using lightning data observations. You can see what I show is one is observation on the upper left. On the upper right panel, it labeled RAD. That means that forecast use the radar observation only to produce the forecast. And the lower left shows the result by combining radar and the lightning observations. You can clearly see when we combine these two, we are able to successfully forecast the reinitiation in front of the old decaying system. So of course, the score is improved by combining these two types of observations. Okay. Nowcasting is very important for hazard prediction, but we still have a lot of research questions to be answered. For example, machine learning is a new technique that shows lots of potential. So on the right-hand side, there is a figure showing one result from a recent study by Han et al. It shows the machine learning technology is able to predict the storm initiation that wasn't exist at all half hour ago, but then 30 minutes later, using the machine learning method, we are able to forecast the initiation. But although there are some false alarms still. Okay, another I want to highlight is another question is the use of geostationary satellite data for nowcasting. This is especially important for regions without radar networks. Okay, next one. So for the coupled modeling, at least three, many questions, research areas, and 3 topics. The first one is, of course, we need still to improve the accuracy of weather models. In order to do that, there are several, at least 5 topics. I think these are all quite very important in order to improve the accuracy of weather models such that these forecasts are useful to drive the hazard modeling. And the second topic is to improve uncertainty prediction. For the high resolution kilometer scale modeling, one question often arises is how to make the perturbation. How can we consider large scale and convex scale perturbations? How can we get both optimally? For the coupled hazard modeling, of course, data archive distribution, this is quite a basic thing, but it's still lacking. Then pre-processing weather data and two-way coupling to model feedbacks, coupled data estimation, these are all important issues. On the right, I'm just showing an illustration that the model resolution really make a big difference. So on the lower right panel, it's a 500-meter model run. You can see this here. The hook echo is successfully forecasted, but at the 2 kilometer, you are not able to forecast the hook echo that caused tornado outbreak. Okay, this slide I list the recent activities by the team. The team worked on a BAMS review paper in the last 2 years entitled Multi-Scale Forecasting of High Impact Weather, Current Status and Future Challenges. This paper has recently been accepted. I think it will be in print pretty soon. So various members participated in international projects such as this project in various regions, some Asian, some in Europe. And of course, our members have a much wider research areas than I just highlighted. For example, they have people doing hurricane prediction, heat wave prediction. I don't have time to highlight their research, but in today's program, I hope you can get a flavor of these researches. There will be 3 HIWeather cross-cutting projects in the next few years. So our task team is actively involved in 2 of these 3 projects, end-to-end value chain evaluation project and toward the perfect warning book writing. So thank you for your attention. So now I can answer some questions.
All right. Thank you, Jenny. So I should have asked everybody to send their questions as they came into your head. But if anybody's got a question, please type it in the Q&A feature of Microsoft Teams. So let me ask the first question about urban.
Mm-hmm.
One of the issues of urban is air quality and heat. In Europe, many people died in one of the heat waves in the big cities because of the extra heat. Is HIWeather focused on that at all?
One of our members is working on the heat wave prediction. He's from India. So because the heat wave is also a big issue for India. So myself is not expert at all in that area, but yeah, we do have some people working on that. I think really the main issue is still it's maybe not that hard to forecast the larger scale, to give advisory of heat wave in a large area. But the problem is when it's combined with the urban heat island, it may make it more difficult.
All right.
Mm.
Right. Okay. Do we have any questions from the other speakers for Jenny?